Okay, so in this lab, we have a dual multi-home setup where we have ISP1 and then ISP2. So we're multi-home because we have connections to more than one ISP, and we also have ISP2 terminating into both firewall or router firewall 1 and router firewall 2. So in this lab, I was going to show you how to configure NAT when you have connections to more than one ISP on one router. I was also going to show you how to change the metric in OSPF when you redistribute that default information. So when you redistribute the default route, so from router firewall 1, the goal here is that ISP2 is going to be our primary. So say that this link right here failed between router firewall 1 and ISP2, we would want router firewall 2 to pick up the traffic, so that way the connection would be or traffic would continue to go through ISP2. In the result, or in the instance where ISP2 failed completely, or both of these links failed, then we would want to use ISP1 as our backup link. So I'm going to show you how to configure NAT. You have more than one ISP. So when traffic is traversing this link right here, we want the traffic to be translated to an address that belongs to ISP2, and then the same for when traffic traverses this link to ISP1. And then we're going to advertise the default routes via OSPF to this layer 3 switch, and we're also going to set a higher metric on this link right here. So this is so router firewall 1 is going to be the primary. This is going to be the backup. ISP2 is going to be the primary WAN connection. ISP1 is going to be the backup. And like I said, in the event that router firewall 1 fails altogether, router firewall 2 will be the redundant router to take over for all traffic flows. In the event that this link right here individually fails going to ISP2, well, then we don't want traffic to continue, or traffic flows to then go to ISP1, which is exactly what would happen since that metric would be higher here. This would be then advertising that default route, that default information via OSPF down through this point-to-point link to this layer 3 switch. So that's where the modifying that metric, and we're going to use a route map for that. And then I'm also going to set up default routes using IP SLA and a tracking object as well. To basically say if this, if the route to ISP, or if this link to ISP2 fails, then we want to plug in the default route to go to ISP1, and then of course with that, the redistributing that default information via OSPF. We want to say that the metric, though, when we advertise the default route for ISP1, it has to be higher than the default route being advertised to this layer 3 switch via router firewall 2. So that way we can stay connected to ISP2, like I said previously, in the event of a link failure. So so ISP1, ISP2, these are just firewall-enabled routers. This is all layer 3, so we have a /30 point-to-point link here, /30 point-to-point link here, and then we have a router that has been configured as a test PC connected to this layer 3 switch as well on its own layer 2 segment. So what I've done so far is I've done nothing more than configured the links between these nodes, configured the IP addresses, and configured the NAT inside and outside for these firewall enabled routers. So okay, so let's start with going into firewall 1. And the first thing I want to do is I want to create an IP SLA monitor to track this right here. So if this was in the real world, I would probably just track the line protocol. Actually, you know what? Actually, I would be tracking a well-known address on the internet. So that way I could determine if if there wasn't a failure directly related to this link, and there was still reachability between this and ISP2, I would definitely want to know if ISP2 is maybe having an internal problem. So both of these actually have been configured with loopbacks of 8.8.8.8. So that's going to be like our simulated internet. So with that being said, what I'm going to do is I'm going to configure an IP SLA monitor, IP SLA 1. I'm going to send ICMP echo to 8.8.8.8, and the source interface is going to be fast Ethernet 0/1. And I'm going to change the frequency to every 5 seconds. So IP SLA, schedule 1, start time now, live forever. Okay, and then we're going to do track 1, router 1. Now, if this was real equipment, it's normally going to be track and then the number you've assigned it, and then IP SLA instead of router. So in here, it's track 1, router 1, and then I believe reachability. Okay, and it is down. And then now what I do is it's down because we don't this doesn't actually know how to get to 8.8.8.8, because if we do show IP route, we actually forgot to turn on IP routing. These are actually I just use routers with Ether switch modules for all of these in GNS3, since they don't actually have there's not like a layer 3 switch that you can use. So I've just gotten used to using these and then changing the icon to resemble what it is that I want. So by default, IP routing was not enabled, so we had to enable that. So let's do show IP route again. And if we see there's no route to 8.8.8.8. So for the IP SLA monitor, I'm going to put in a tracking or a static route to 8.8.8.8. So, and the reason for this is because we would have an issue where the IP SLA monitor would be attempting to ping 8.8.8.8, and if we didn't put that static route in the routing table, and the default route to ISP2 was relying on that tracking object to be up, it would kind of be like a circular problem, is that the route would be relying on track 1 to be up, and then track 1 would be relying on that static route. So when you put that static route to that destination that you want to track, you can kind of tell the router, I always want you to use this this next hop to reach this. So we can kind of dictate which way we want that traffic to go for that ICMP echo request for our IP SLA monitor and kind of designate 8.8.8.8 as the IP address of choice to ping by putting that static route in the routing table. I hope I explained that well enough. Sometimes I get a little bit mixed up when I'm making a video. It's a little bit difficult to kind of keep things straight in my head at that point. But anyways, so we have our tracking object. So we'll do show track 1. Reachability is up. So now we're going to link that tracking object to our default route for ISP2. Now, I should have probably put ISP1 for the primary and ISP2 as the backup, but whatever. So we'll go IP route 0.0.0.0, 0.0.0.0, 172.17.21.1, and then track 1. So this route, this default route, will only stay in the routing table as long as that tracking object is up. If 8.8.8.8 is not reachable, and remember, if this was the real internet, we would be tracking something way out there on the internet to be able to verify that if the ISP was having some kind of internal problem, and then that would go down, and then this static route would be pulled. And now the point of this is because now for our backup, this 172.16.20.1, we're going to put this static route in the routing table with a higher administrative distance. So it will only go into the routing table if the primary route goes down, which is relying on that tracking object. So we'll go IP route 0.0.0.0 and 172.16.20.1, and then I'll put 10 for the administrative distance on that. Okay, and kind of just to show you how that's going to work, let's go to fast Ethernet 0/1. Just shut that down, which is going to cause that tracking object to fail. Actually, I believe the static route would be pulled anyways because the line protocol would be down and the interface would be administratively down. But I should have actually paused the status of, or suspended it to give you a better idea. But anyways, I think that the point is the same, is that now we have that static route 172.16.20.1 going to ISP1. So let's do a no shut on fast Ethernet 0/1. Tracking should come back up. Oh, there we go. Yep, show IP route, and now we should see that we have our default route via 172.17.21.1 back to ISP2. Okay, so I know that was a little bit long-winded for this. I'm going to try to speed things up here a little bit as we go. So, okay, so now we have our two routes. The next thing is we want to configure NAT, and these are just these are not transport links where we're going to have a NAT pool or anything like that. These are all just /24 /24. So we're going to NAT. We're just going to NAT the traffic to the IP address on the interfaces right here. So the way we're going to do this, since we have more than one ISP on this router, is we're going to use a route map. But the first thing I'm going to do is just create a quick and dirty NAT access control list, just permitting any. Okay. The next thing I'm going to do is I'm going to create a route map for both ISP1 and ISP2, which is what we're going to eventually plug into our NAT statement. So I'm going to go route map I'm going to name it NAT ISP 1 permit 10. And so now what we're going to do is we're going to match the access list, and then we're going to match the interface. Go match IP address, and that access list name was NAT, and then match interface. This is for ISP1, so we're going to match interface Fast Ethernet 00. Okay. And now the same thing with ISP2. What's happening? Okay, route map NAT ISP2. We're going to match the same access list because we're just going to do a very quick configuration, just NAT everything. Match IP address NAT, match interface, and then for ISP2, Fast Ethernet 0/1. Okay, and now we configure our NAT statements. Like I said, I already configured the outside, so this is IPNAT outside, IPNAT outside, IPNAT inside. So now all we have to do is go IPNAT inside source route map. We name the route map NAT ISP1. And like I said, we're just natting to the address on the interface. So with ISP1, we're going to NAT whatever. So we have 172.16.20.2 on Fast Ethernet 0/0. So we're going to tell it NAT everything for ISP1 to this public IP here on Fast Ethernet 0/0. So we'll go interface Fast Ethernet 0/0 overload, and that's done. Now for the second one, since we did NAT ISP2 for our route map, we'll just change this. And then ISP2, Fast Ethernet 0/1. Okay, so that should have successfully configured NAT for both these ISPs. I would try to test it right now, but I don't think it's going to work because it's going to send this from the source, either this or this, so there's no NAT is going to be occurring, unless I created a loopback. Anyways, we'll wait and test this. I'm going to remember this, and I'm going to do a NAT debug once we get OSPF going, and we will see by the, depending on which provider the traffic's going out to, we'll make sure that it's being natted correctly. So really quick, before I get into the OSPF configuration, let me just configure router firewall 2 really quick, which isn't going to be that complicated because we just have one link to ISP2 here. So let's go create our NAT access list. And then just a standard NAT statement. So IPNAT inside source list NAT, and then interface Fast Ethernet 00 overload. And then I also, actually, I also need to configure the default route as well. And we also need to use a tracking for that as well. Since if ISP2 were to fail altogether, we would need that default route to be removed, so that way via OSPF router firewall 1 would advertise the default route for ISP1, the backup. So same thing as before. So IP SLA 1. I'm going to try to do this extremely fast. Source interface phase 00. IP route. Whoops, and we're going to do via 172.17.21.1. How did that? Oh, and I need to enable IP routing. Interesting. I'm not sure why that is. Why or how that is up. Okay. It was just. It's a weird thing that happened. Okay, so now we do IP route. 8.8.8.8.8, 255, 255, 255, 255 via 172.17.21.1. And we'll give that a minute. That should come up. I need to do ping 172.17.21.1. Make sure we have reachability, and we do. And okay, there we go. So reachability is up. So let's tie that default route to that tracking object. So IP route. You know, 172.17.21.1. Tied to track 1. And it should be in the routing table. There we go. Okay. So let's, so we have NAT configured, we have our default routes configured. The only thing left is to configure OSPF and advertise that default information. But then, like I said, the last step is to use a route map to say that for ISP1, I want that to be advertised with a higher metric down to this layer 3 switch. In the instance that maybe this link fails and we want to stay on ISP2, and this is going to have a higher cost since this is our backup router firewall. So let's start with getting OSPF fired up. So we'll do router OSPF 1 to router ID 101.1. And then we have 10.255. RIA 0. What am I doing? And then I'm just going to add this in here. Just plain and simple, just to show you what happens, you know, if we don't modify anything. Network. Okay, and then once we configure OSPF on this layer 3 switch, we should see some adjacencies form. And then before we set the cost higher, we're also going to see equal cost load balancing with the default route as well, since it will want to go here and here, since we haven't adjusted the influence of the metric yet. So, so let's go router OSPF 1, router ID. Oh, again, IP routing. God, I always forget that. Okay. And we'll add network 10.255.254.2. Okay. Adjacency there. 255.2. And we're going to add this network here. And we want to make that a passive interface. this isn't an SVI. This is just a layer 3 interface. So we'll go passive interface. It's just 1/1. We don't want to send hellos out of that. Actually, the best practice is to set passive interface default and then manually enable those links or those interfaces is non-passive one by one. So let's do show IP route, and there we go. There's our default route via 10.255.255.1 and 255.254.1. So we're going this way and this way. And the reason why we want to influence the metric here is because these are, like I said, these are firewall-enabled routers. We don't need a situation where we're going out here, and then, traffic is coming back in here. I guess, actually, I guess in this example, it actually doesn't really matter because these are two different IPs. We're not dealing with the situation where we have like a DMZ and traffic is coming in, and that traffic could come in one way and then go out the other way. So really, I guess this would work if we did actually, let me go all the way to the test PC. Do a ping of 8.8.8.8. And there we go. And obviously, NAT is working. I don't know which one of these it went out of, since it is load balanced between the two. Okay, yeah, so here we go. But anyways, the other reason why we would also want to adjust this cost as well is because, like I said, this is supposed to be used only for a backup. So if this link failed, then we would still, well, I guess adjusting the default, influencing the metric via that route map that we still have to do would take care of that. So, but either way, I'm going to influence the metric on this link anyways, since this is supposed to be the backup, and we don't want to be performing any sort of load balancing. So we'll go fast Ethernet 1/15, and we're just going to do bandwidth 10,000. So what that's going to do is say this is this doesn't actually change the bandwidth on the link. It's just going to tell your routing protocol, OSPF in this instance, that this bandwidth, think that this bandwidth has 10 megabits per second, and since cost is OSPF's metric, that is going to influence that metric, which will influence the cost, and we should see that default route via this way should be gone, and it is. So we have our default route via 10.255.254.1 via fast Ethernet 1/14. So if this link were to go down, then this link would be the next best link. Now, again, the problem is that if this were to go down, just this link between firewall 1 and ISP 2, well, traffic would still go up here because this has less cost. And since we didn't add the route map in OSPF to adjust that, that's why that would happen. So that's the next step. But before I do that, let me just do an example. Let me take down this link. Wait for the tracking object to go down. Did so. Do show IP route, and so now, yes, we have traffic wanting to go through ISP 1, and just to show you, and then we can also test NAT at this point as well to make sure that things will be translated correctly going out through ISP 1 with our NAT route maps. But first, let's go to layer 3, the layer 3 switch, and do another show IP route. So it's still going to want to go via fast Ethernet 1/14. That is the whole point of this route map when we throw it into OSPF for the default information, is we want to say, oh, if ISP2 is still alive, we prefer ISP2 because maybe ISP1 is a more expensive option or something. So even though this has a higher cost right here, we still want to go this way if only just one link failed going to ISP2 and save this for the backup. And but just to show you what's happening right now with everything set by default, you see that we still have a default route going out Fast Ethernet 1/14, which now will go out to ISP2. But before we change that default information originate command and add a route map, let's just test our NAT configuration and make sure that we're translating correctly. So I'll do a debug IP NAT and do a I guess I can do it from here. Well, that's odd. So NAT is working, but we don't have reachability. It looks like we don't have return traffic for some reason. Hold on one second. Let me see if I can figure this out. I'm gonna pause the video for 1 second. Okay, I'm back, and I'm a complete idiot. So the reason is because this default route has nothing to do with pinging 8.8.8.8. I am so used to using 8.8.8.8 as a loopback to simulate internet, and then since I created those IP SLA monitors where I have that static route, it's going out. When I ping 8.8.8.8, it's going out Fast Ethernet 0/1. No, it's trying to, no matter what. So our NAT is correct. So what I'm going to do is for a test internet to test this, I'm just going to I'm going to go up here and add another loopback. But anyways, let's do now let's do our ping and make sure NAT is natting correctly. So yes. So as you saw, sorry for the delay as well, by the way. It was my fault, but when traffic's going out this way with our NAT route map, it's being natted to an address that belongs to this ISP. When it's going to ISP1, it's being natted to an address that belongs to this ISP. So that is how you configure NAT when you have more than one providers connected to one router. You just create that route map where you define your access list and you define the interface, and then you plug that route map into your NAT statement. And if you were using a NAT pool, say this was say for ISP2, like this was a /29 for your transport, and they were routing like static IPs to you, and you created a NAT pool, it would be the same thing. It would be IP NAT inside source route map, and then instead of interface, you would go pool to define the NAT pool you would want to NAT those internal addresses to. So, okay, so the last thing we have to do, and wow, I'm already almost 45 minutes into this video. I did not intend to have it be this long. So, I apologize to everybody out there for my mistakes. I'll try to do some video editing to clean some of this up a little bit, make it a little bit speedier. So, okay, so now what we want to do is, like I said, so I just showed you when I suspended this link, traffic was still going to firewall 1 out to ISP1. So going through firewall 1 to ISP1, when indeed we want, when this link fails, even though there's a higher cost, we want the traffic to go to ISP2. So we can fix this. So what we can do is we can create a route map on firewall 1. But first, without some access control lists to define some parameters. So the first thing we want to do is, so in our route map, we're going to define the network or the IP address, which is going to be all zeros because it's our default route, and then we want to define the next hop. So we're going to do IP access list, and my naming isn't going to be consistent because I'm just doing this for an example. So I'll just do OSPF default. And I'm going to make it a standard access list. Okay, and then since we want to adjust the metric on this, we're concerned with the next hop for ISP1. We're gonna leave this alone. I believe if it's not in the route map, it will just function as normal. So we're going to do IP access list standard OSPF ISP1 next hop permit 172.16.20.1. Okay. Now the other thing is, now what we need to do is I need to temporarily suspend this link because I need to look at the cost to get to ISP2 through Firewall 2, so I can adjust the so I can tell this route map to set the cost just a little bit higher. So of course I'm going to be waiting on the dead timer now. Let me just go in here and shut down the interface so I can tear down that adjacency immediately. Oh, we're using let's see, external type 2 route, so it doesn't add the internal metric. So let's go to let's see, I have all the same open. So we will go to ISP2 and router OSPF1, not ISP2, Firewall 2. Let me get rid of these two because one of these I selected to stay on top. So now whenever I open something, it wants to hide itself, not just pop right up. Okay, so router OSPF1, no default information originate, and then we'll go default information originate metric type 1. And then we're also going to want to do the same. Now, when we put in our route map, we will put our route map in there as well after that. So, so I'm not even going to bother with Firewall 1 because I'm going to end up doing that when I put this route map in there. So now I should see a default route with the internal metric attached to it, which I think it would probably be 11 if we set that to... Okay, come on, what's happening here? No neighbor. Come on. Oh, here's a classic GNS3 issue that I was talking about, that I was trying to blame the that previous my mistake on. So go interface fast Ethernet 1/15 shut, no shut. See what I mean? That right there is what's irritating to me. That doesn't happen on physical equipment. Okay, yeah, metric is 11. So, and we didn't adjust. Well, I guess we wouldn't have to adjust the reference bandwidth in OSP. These are just 100 megabit per second links. But so we see that just as I predicted, the cost is 11 to get to this. So we just want to set this a little bit higher. I'll set it to like 15. But first, I want to go in here, do a no shut. Unpause this. Router firewall 1, and we'll do route map OSPF default permit 10 match IP address. What did I name that? match IP address, OSPF, I believe it was just OSPF default. I can do show access list as well. OSPF default, okay, and then match IP next hop is OSPF ISP1 next hop. And then what we want to do is set metric to 15. Okay, so now let's go back into OSPF. So we'll go router OSPF1. We do no default information originate. And now we'll go default information originate metric type 1 route map OSPF default. And let's go back down to the layer 3 switch and see what happens. So we should have the typical I don't know. I may have done something wrong. So let's just give it 1 second and see if anything changes, and then if not, I believe we'll have to add the other this other connection into the route map. Which honestly, I thought that with it not being in there, I thought it would just ignore it. Let me make sure I have an OSPF neighbor first. So, you never know, we could have that same issue happening again. So we do. So yeah, so neighbor ID 1.1.1.1, fast Ethernet 1/14, and we're not seeing any default route. So let's go back up to router firewall 1. And let's see here. Okay, so we're gonna do let's do a do show route map. And we have so we have our NAT route maps that we confirm we're working, and then the OSPF default. So there's an implicit deny in this route map, so that's why it's not advertising the default route for ISP2, our primary, because it's not in here. So what we need to do is just create another access list that defines the next hop for ISP2, stick it in there, and then don't set anything for the metric, because we just want the metric to be the default. So let's go IP access list standard. And then we'll name it just like the other one. So OSPF-ISP2 next hop and permit. And so the next hop would be 172.17.21.1. So 172.17.21.1. Okay. And so we'll go route map. And this is going to be a little bit out of order because I'd prefer this to be, and I think that will be fine, but yeah, it should work. So we'll do route map OSPF default, and then we'll do a permit 20. So we want to add that as our second statement, and then just do match IP address and that OSPF default. So the quad 0 route, and then match IP next hop, and then this access list we just created. Whoops. And that should do the trick. Okay, there we go. So now we have our default route being advertised via see 10.255 254.1 via fast Ethernet 1/14. So let's see if this worked. If this worked, then we take down this link right here, we should still see traffic being destined for ISP2, but via router firewall 2. So let's suspend this. So that route map should then advertise. So we'll still have a default route in firewall or router firewall 1. But since we stuck that route map in the default information originate statement in OSPF, it's going to advertise that with a higher metric than what it is to get to ISP2 through this route. So if you look, we do see, so that route came out of the routing table, and so we have via 172.16.20.1, so ISP1. So let's see what OSPF is doing with it. Is our route map working? If it is, we should see the default route via Fast Ethernet 1/15. Perfect, and we do. So, and then the final test is let's just take down ISP2 altogether, and then we should see our backup WAN connection through router firewall 1 to ISP1. With a higher metric. Yep, and there we go. So this is going to take us out through router firewall 1 to ISP1 since it's now advertised with a higher metric. So we set the metric to 15, and with that being a static route, the external metric, so 1, we have 16. And so there you have it. So in conclusion, let's make sure we can send out a quick ping. So in conclusion, what we've covered in this lab is how to configure your IP SLA monitor, and then bind that to bind a tracking object to that, so you can set up a static route to depend on that tracking object. And if that tracking object fails, it pulls that static route out of the routing table, allowing for a secondary weighted static with a higher administrative distance to go in the routing table. And then you've also learned how to configure NAT using a route map when you have more than one ISP connected to the same router. So like I said, ISP2 traffic is going to be NATed accordingly. ISP1, it will be NATed accordingly. And then finally, how to configure OSPF to redistribute that default information, and with a higher metric or a lower metric, depending on what the next hop is. So like I said in this example, if ISP2 is primary and say this link fails and you want to use ISP1 as a backup and only a backup, well then you can still hop over to router firewall 2 to still get to ISP2, since you can configure this to advertise that default information with that higher metric to override the to be higher than what the cost is over here. All right, that's it. So sorry for the lengthy video. If anybody has any questions, please feel free to send me an email. You can reach me at rob@rmtechcentral.com, or leave a comment in the comment section below. And if you like this video, please give it a thumbs up. And if you're not subscribed to my channel, I would really appreciate it if you would subscribe. And until next time, I will see you in the next video. Thanks for watching.